So today, let's see, it's Wednesday, right? It is Wednesday, April 9th. Let's get that all down. Algebra 2, we're in Unit 1. And today is day 11 of Algebra 2. Okay, day 11, Wednesday, April 9th. Okay, so like I said earlier, we are going to focus today on finding the discriminant. What is that? We're going to write down that word one more time and just make sure we understand it. Discriminant. Okay, it's a funky word to say. Discriminant. Everybody say that. Discriminant. Discriminant. Beautiful. Discriminant is the word that describes the value that we get under the square root in the quadratic formula. And that value is, we say D equals B squared minus 4 times A times C. So coming from a quadratic equation that is written in standard form, where we have an A term, a B term, and a C term, we use those numbers in this formula to find the discriminant. And here's how we use the discriminant. Basically, without solving the whole quadratic and getting the answers, if we just do this part, there's a few things that we can know about the equation. And I'm going to give you a list of things. There are 3 options. First, your discriminant might be equal to 0. Your discriminant might be less than 0. Or your discriminant might be more or greater than 0. Now, if you are getting a discriminant that is equal to 0, what this means is that after plugging in the numbers that you get for B, for A, for C, when you do all the math, you do B squared minus 4 times A times C, the answer you get is 0. It will for sure be the number 0. If the discriminant is 0, this will tell us that there is one answer for x in the equation. So underneath D equals 0, we're going to write one real solution. Okay. One real solution, meaning that there will be one number that is our answer for x. This will make more sense later on when we do some examples. Now, if the discriminant is less than 0, if any number is less than 0, what kind of number is that? A positive or a negative? A negative. So what's really being said here is when your answer is a negative number, so we're going to write under here to remind ourselves, when D is negative, So when we get a negative number as our answer for the discriminant, this means there are no real solutions. Or 0 real solutions. Meaning, just like we talked about very briefly one day, whenever you have a negative number that goes underneath a square root, that's impossible. It doesn't exist. You cannot have a negative number underneath a square root. So we would say that there are no real solutions. So there's our second option. And the third option is when the discriminant is greater than 0. So when any number is bigger than 0, what kind of number is that? Negative or positive? Positive. This is telling us that whatever numbers we plugged in for B, A, and C, they come out to be a positive answer. So underneath that, I'll write positive. And when we get a positive number as our answer, this tells us that there are 2 real solutions. Okay. So these are the 3 scenarios that we will see anytime we're doing a quadratic equation. So, for example, let's say, let me get another color. For example, let's say I have an equation that says negative 3x squared plus 10x minus 1 equals 0. Let's say I have this equation. To find the discriminant, we first want to do the same thing when we're using the quadratic formula. We want to identify our A, B, and C values. So in this problem, what is the value for A? Negative 3. Good. That's our A. What's the value of B? 10. Perfect. And how about C? Negative 1. Good. So we have our values for A, B, and C. Now, instead of using the whole quadratic formula, let's just find the discriminant. So, I'm going to rewrite D equals, I'll leave a blank for my B squared minus 4 times a blank for A times a blank for C. This is how I'll start my problem. Okay. Above that, I'm going to just rewrite it. B squared minus 4AC. Okay. So what number would go into my first blank? 10. It will become 100 though, you're correct. So my B is 10, so I am going to plug in the number 10. Okay. Okay. And just to show where all of that's happening. There we go. So we have 10 squared minus 4 times, what number goes here? Good, -3, that's our A. Perfect. And I'm just going to stick some, oh, that is a dark green. Hang on. Stick some colors on here to help us see it. All right, so there's my A. What goes in the last blank? -1, my C value. There we go. Perfect. So I have 10 squared minus 4 times -3 times -1. Now, recall we talked also about the order of operations a little bit yesterday. According to the order of operations, which thing do I need to do first? My exponents, yes. So we have 10 to the second power, which means 10 squared, which also means 10 times what? 10 times 10. Perfect. What is 10 times 10? 100. Okay, so we have 100. And what do I do next here?
Multiply.
Yes, we're going to multiply. Then I heard somebody start. They said -4. Yes. Beautiful. -4 times -3 times -1. -4 times -3 gives us what? +12 times -1, -12. So, if I get -12 as my answer, how do I bring that down to my 100? We're just going to write -12. Perfect. Okay, and what's my last step? Equals 88. 100 minus 12 is 88. So the discriminant is 88. This means that whenever I solve this equation, 88 will be the number that is underneath the square root. So now that we have found our discriminant, let's use this little key that I gave you, this guide, and let's see if we can decide how many solutions will I get when I solve this equation. Will I only get one answer? Will I have no solutions? Or will I have two x values, two real solutions? What are we thinking?
You'll have two real solutions.
Two real solutions. How did you know that?
Because U times D is greater than 0.
Perfect. So we got our discriminant, or D, that is 88, positive 88. Because we got a number that is greater than 0, we got a positive number, we know that there will be two real solutions. So if we wanted to abbreviate that, because there will eventually be a question like this, where I say, what's the discriminant? How many solutions? Instead of writing out two real solutions, a good way to abbreviate is 2RS. So we can write that over here as well, 2RS. We could do the same thing for one real solution, 1RS. And then 0RS. Just a way to write it a little more quickly. Okay, now before we go on, I would like 2 questions. I want, whether you understand this really well or you are totally lost, either way, I want you guys to try to come up with 2 good questions that you think would be helpful to somebody in this room. So think on it for a minute. 2 questions. If you think of one, just pop your hand up or shout it out. Is 0 just a replacement here?
Yeah, because it's at the end of each equation, right?
Yes.
So it's just there, so we know what happened.
It's just there. Yes, that's actually a great question. So why is every equation that we're solving equal to 0? That equal to 0 tells us that we don't need to rearrange our equation before we start solving it. So you'll notice on that worksheet up at the front of the room, some of the equations are not equal to 0, such as number 7. We have n squared minus 10n plus 22 is equal to -2. This one would not be ready to solve until we get that -2 on the other side. That way we know we are in standard form, we're ready to solve it, we have our values. That's a great question. So if your equation is already equal to 0, you know you're ready to do stuff with it. If it's not equal to 0, that means we need to get it equal to 0 first. Thank you, that's a great question. Okay, I want one more question.
Can we do one of those that's not equal to 0, just like as a refresher?
Yeah, absolutely. So when you say not equal to 0, you mean like the one I just pointed out, number 7?
Yeah.
Okay, let's do it. Let's do it. Thank you. Does anybody still want to see this work? Okay, I'm going to go ahead and title that as my first page. And we will start another page. So page 2. Day 11, notes continued. Still algebra 2. Okay, and so here is an example where our equation is not equal to 0. So let's actually use number 7 as an example. And I'm going to change the n to x, just because whenever we get to the quiz day, you will only see x. I won't use other letters, so we're just going to get comfortable with that now. So this is number 7 on that worksheet. X squared minus 10x plus 22 equals -2. Okay. So we're looking at this equation, and the first thing you would notice is that it is not equal to 0. So who has an idea what would I need to do here to get my equation equal to 0? Yes, we need to add 2 to both sides, because if there's a -2 over here, the only way to get rid of it would be to do the opposite. -2 plus 2 will give us 0. So if I add 2 here, we need to add 2 on the other side as well. So our equation stays equal. Okay. And then we could just bring everything down and rewrite it. And we'll have x squared minus 10x plus, what does 22 become? 24. Nice. 24. And now we're equal to 0. Very nice. Okay. So whenever you have an equation that's not equal to 0, whatever is on the other side that's not 0, we're going to do all of the opposite things to move it back over with the other numbers. Okay? So now that we've rearranged this equation, let's see if we can find the discriminant. And I'll rewrite that up here. Remember, discriminant is just b squared minus 4 times a times c. So first things first, what is my value for a? 1. Good. Here, let me get another color. Okay, so my a is 1. How'd you know it was 1? I don't see a 1 there.
Because it's just one variable.
Because when there's not a number, you assume it's 1. There's only one of these x squareds. It's only written once. There's 1. Okay. What's my b value? -10. And my c? 24. Good. Now you might get a different answer if you didn't rearrange your equation. With a c that is 22, it would definitely affect your answer a little. So that is important to check. Okay, so now that I have my a, b, and c identified, how am I going to find the discriminant? Yeah, we're going to start with that -10b squared. So d equals -10 squared. And then I'm just going to copy down the next parts as I go. What comes after that? -4 times a, which is 1. Perfect. Times c, which is 24. Beautiful. Okay, so we have all of our numbers plugged in. Now let's see what the discriminant is. Now, what is the problematic thing about having a negative number that we square? What is the most common mistake we've talked about when doing this? Yes, a negative number times a negative number will always give us a positive number. So it does not matter if your b is positive or if your b is negative. When you're doing a number squared, you're taking that number times itself. You will never get a negative answer when you square something. So even though we're taking -10 squared, we're really doing -10 times -10. And 2 negatives give us a positive. So what is -10 squared? 100. Good. So we have simplified that first part. And what comes next? -4 times 1 times 24. So what does that give us? -96. Okay, so now I have 100 minus 96 equals 4. So our discriminant is 4. Now, how many solutions? Let's look back at our little chart. 2. How do you know there's 2? Because we got a positive number for our discriminant. Since it's positive, there are 2 real solutions. And that's what we would write. Perfect. Perfect, perfect. Now I want to show you something else. This isn't something that you will necessarily be tested over, but I think it helps to see things visually sometimes, and I found this helpful when I was learning how to do it. But I'm going to go back to the previous page and look at this little chart for a moment where we wrote out all the different types of solutions. And I don't have a ton of room left on here, so I'm going to use sticky notes to show visually what this means. I'm going to use 3. If anybody does not have sticky notes at their table and they're wanting to copy what I'm doing, let me know. I have lots of extras up here at my desk. So I'm going to do this. Now, whenever we are looking at quadratic equations like we have been, we can graph these equations. They are a bit difficult to graph, but I want to just show you what that graph looks like based off of how many solutions it has. When we find the discriminant and the discriminant is 0, telling us that there is one real solution, your graph will look like this. I'm just going to draw a little cross mark, and then I'm going to make 1 point right here, and from there I'm drawing this shape. This means that if you were to graph this equation, this is called a parabola. We'll talk more about these later. It means that it will be touching the x-axis. There will be one x value just at 1 point. One solution means it touches at 1 point. So we could write D equals 0, 1 real solution. Okay, let me actually scoot that over just a tiny bit so I got a little more room for the others. Okay, so that's what that graph would look like. Now, whenever we see the next option, the negative answer for your discriminant, or D is less than 0, we have no real solutions. This is going to mean that your graph doesn't touch the x-axis. This is the x-axis, the one that goes left to right. It doesn't touch it at all. There would be no x values found here. So when D is less than 0, no real solutions. And does anybody have a guess or an estimate of how many times this parabola might touch the x-axis when your discriminant is positive? 2. Yeah, it's that simple. There's 2 real solutions, so it's going to touch the x-axis 2 times. And that will look something like this. So when D is greater than 0, 2 real solutions. And I think sometimes this just helps, I know it helps me personally visualize what we mean by solutions and the reason why sometimes there's 1, sometimes there's 2, sometimes there's none. It's because we're literally talking about how many times we're touching the x-axis. You either touch it once, you touch it not at all, or you touch it twice. You can't ever have more than that, you can't have less than that. Only 3 options.
Question.
Yes.
What if it were in between the y? How do you get that?
Ah, what if it were in between the y, like this? So, in these scenarios, whether it touches the y-axis or not doesn't really change anything. We're only worried about the x values, but that is a really great question. Yeah, it's strange because we're used to looking at all of the things, but we're not too worried about the y-axis this time around, just the x. Now this is misleading because now I have 2. I should get rid of that. Let me redraw that one. Here. 1. So yeah, it could be crossing the y-axis and that would be fine. It's just that it only touches there once. Okay. Okay. There we go. So, now that we've got some of that under our belt, we're going to do some practice with the discriminant. And for the first half of today's class, meaning whenever we take our break around 10:20 or so we've got about 30 minutes until then, my only goal for you is to feel really good about being able to find the discriminant and being able to tell me how many solutions there are. That's the goal today. If we got that, then you are on track. Okay? Can I move this or does anybody still need it? All right. You just tell me if you change your minds, guys. So let's do a little more practice with that, and I want you guys to try just a couple on your own that we'll look at together in a moment. And let's see, specifically, I would like, I'll copy down a few from the worksheet that I want you to try. I would like you to find the discriminant of number 5, which is x squared minus 11x plus 19 equals -5. I would like for you to find the discriminant of number 6, x squared plus 7x plus 15 equals +5. We already did number 7 together, so next number 8, x squared plus 3x minus 12 equals 6. And let's stick one more on there. Number 9. 6x squared minus 18x minus 18 equals 6. So these are all on your worksheet. The only thing that I did different is I changed the other letters to x. That's just what I prefer. So you're welcome to copy off this. You're also welcome to do it on the worksheet, however you prefer. I'm going to give you a little bit of time to try these on your own, and I'm going to walk around the room, see how we're doing with them. If you finish before the end of class, then you have achieved your goal, and you're welcome to go early. Just raise your hand and let me peek at it before you go, just to make sure that we're in a good place. So we're finding the discriminant and saying how many solutions. So find D. How many real solutions? Okay, I'm gonna pause our video. And we'll see how we do. All right, so number 5. Who can walk me through number 5? How did we do this?
I'll try it.
All right, how do we do it?
Okay, so first we need to get rid of the 5.
Yes.
So we're gonna add 5 to that and then 19.
Perfect.
And that's gonna leave us with x squared minus 11 plus 24 equals 0.
Perfect. So now we're in standard form. Okay.
And then you're gonna label your A, B, and C.
All right, so what's my A?
X,
Yeah, my A is, there's just an X, so what number does that mean it is? 1. What's my B?
negative 11,
Good, and my C?
24.
Perfect. This is something I saw a few people would mess up, is they would fix the equation so that 24 was the number at the end, but then they would still say that C was 19. You got to rearrange first, then you decide A, B, and C. Just like when we would factor. After you factor out the greatest common factor, you have a new A, B, and C. Okay, so where did you go from here?
So from there I started using the formula,
Okay,
and then I made it negative 11 squared minus 4 times 1 times 24.
okay, perfect. Negative 11 squared minus 4 times 1 times 24. And what did you do next?
Then I did negative 11 times negative 11, which gives me positive 121.
Perfect, 121.
And then I took my negative 4 and multiplied it by 1, and then also by 24.
Perfect.
And I got negative 96,
Perfect, negative 96.
which is 25. 121 minus 96 is 25.
Beautiful. So 25 is the discriminant
And it's
for number
2
5. Yep, 2 real solutions. Good, 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 good. Thank you, Amanda. So I'm going to write that on my worksheet just so I can remember that that's the one we just did. That was number 5. And we got a discriminant of 25, and there's 2 real solutions. So I just wrote that on my paper. Okay, perfect. Who can guide me through number 6? And we will do questions after we get all the answers. Number 6, any takers? Yes. All right, what did you do, Shanice?
I minus 5 from 15.
Good, so minus 5. Okay, what did you do next?
I brought everything down to the x squared plus 7x
Mm-hmm.
plus 10 equals 0.
Perfect. X squared plus 7x plus 10 equals 0. Perfect, perfect. And what did you do next?
I set up a formula, which is b equals
Mm-hmm.
7 squared
Perfect. 7 squared.
minus 4 times 1 times 10.
4 times 1 times 10. Perfect. So 7 being B, 1 being A, 10 being C. We've got all of our numbers plugged in. And where'd you go from there?
I did 7 times 7,
Mm-hmm.
which is 49.
Perfect. 49.
Negative 4 times 1 times 10.
Mm-hmm.
And I got negative 40.
Perfect. So 49 and negative 40.
I got 9.
Perfect. So we get a discriminant of 9. How many solutions?
I got 2.
2 real solutions. Perfect. You're going to notice that that is the most common answer you will find with discriminants, is that you're mostly going to get 2 real solutions. That's the most common answer you'll see. Perfect, perfect. So I'm going to write that on my paper too. For number 6, our discriminant is 9. And there are 2 real solutions. And I just stuck it on like that. Okay. Thank you, Shanice. Would anybody like to take on number 8? Kiana, absolutely. Tell me how you started.
I subtract 6 from 6 and 12.
Good. Subtract 6 from 6 and negative 12.
Then I got x squared plus 3x minus 18.
Good.
0.
X squared plus 3x minus 18 equals 0. Perfect.
I kind of got on the flow of things, so I didn't do that formula on the side.
Sure, what'd you do?
It came natural to me, so I just put E equals 9 plus 72.
Okay, 9 plus 72. Now, how did you get the 9 and the 72?
Okay, so I did the 3 square root, which gave me 9.
Perfect.
And then I did the negative 4 times 8 times C.
Perfect. And perfect. 72. Beautiful, beautiful, beautiful. Okay, so what'd you do next?
Equals 81
Equals 81.
to RS.
Perfect. So again, a positive discriminant of 81, 2 real solutions. For number 8, I'm going to write that on my worksheet as well. Discriminant is 81, and there's 2 real solutions, 2RS. Good. Okay, last one. Who wants it?
I'll do it.
All right.
Alright, so first I minus 6 from the positive 6 and the negative 18.
Perfect.
And I brought it down and I got 6x squared minus 18x minus 24 equals 0.
Good.
And then after that, I plugged in my numbers to the formula, which was D equals negative 18 squared minus 4 times 6 times negative 24.
All right, so negative 18 squared times 4 times 6 times negative 24. Sorry, my work's getting a little sloppy here.
And then after that, I times 18 and 18, which I got a positive 324.
Perfect. So 324.
And then I took negative 4 times 6 times negative 24.
Mm-hmm.
And I got a positive 576.
Positive 576.
And D equals 900, so that would be 2 real solutions.
D equals 900. 2 real solutions. Nice. Very nice. Okay, so how are we feeling now that we've done a few together on our own? The goal was to be able to find the discriminant and tell how many solutions. Do you feel that we have reached our goal? I think so, from what I've heard. That's pretty good. Okay, if you feel good about this, if you think you've met your goal of knowing this, you are free to go on your break. We are going to come back at 10:45, and I'll write a little sticky note of that. If you are still feeling shaky on this and would like to ask any questions, or if you just want some more practice with me, feel free to stay for a minute and we can talk. But you guys enjoy a break. 10:45, we'll be back. Pause that. So we are back from our break. During the first half, we have mastered the discriminant. Okay, that is the b squared minus 4ac. Solving that, I think we've all done a really nice job with that. So we're going to just go one step further and connect this to the quadratic formula now. So I'm going to start a new page, and I will title it first. Algebra 2. And we're still day 11. Notes. Continued. And we are on page 3. So, up here at the top, I'm just going to rewrite those formulas so we have them in our arsenal. They just exist over here. So, discriminant D equals, zoom in a little here, B squared minus 4 times A times C and then we're going to talk about a way to make the quadratic formula a little bit simpler now that we do have a formula for this part, the discriminant. So, the quadratic formula when we're solving for x, we'll say that we have x equals negative b plus or minus the square root of, and now I'm going to use a different color, b squared minus 4ac. All over 2 times a. And this is where we see the connection between the discriminant and the quadratic formula. Something that I have found helps keep track of what is happening when we're using the quadratic formula is simplifying this formula to this version. We will instead say x equals negative b plus or minus the square root of the discriminant all over 2 times a. So what's nice about finding the discriminant first is now we have a much simpler formula to work with. All we have to do now is plug in 3 numbers rather than 1, 2, 3, 4, 5 all at once. And here's how we get that. So, this is basically going to be your personal preference, whatever you find more making sense for you. If you like finding that discriminant first and then using a more simplified version of the formula, it might help us keep our steps more organized. If you prefer to do it all at once, that is your prerogative. You can do that. That works too. But let's kind of look at how much faster the process gets if we find that discriminant first. So what I'm going to do now is look back at our second page of notes at the answers for the discriminants we got on those problems. So let's start by peeking back at number 5 on that worksheet, where we had the equation x squared minus 11x plus, it was originally plus 19 equals negative 5. So I'll write that original problem one more time. Now, when we went through and solved this problem and we found the discriminant, the first thing we had to do was get our equation equal to 0. That way we have the correct values for A, B, and C. So I'm just going to rewrite that step so we don't forget. We just needed to get rid of anything on the other side of the problem, which in this case we had a -5, so we added 5 to both sides. Which brought our equation to x squared minus 11x plus 24 equals 0. And our A, B, and C values became 1, -11, and 24. So I'll just rewrite the A, B, and C again, just so I have it kind of labeled. And whenever we did this problem, what did we say our discriminant was for number 5? 25. We got a discriminant of 25 when we did this earlier. So now we have a discriminant and we still have our values of A, B, and C. Let's try using this second version of the quadratic formula and see how long it takes us to find our answers for x. Now because our discriminant is positive, how many x's will we find? 2. There are 2 real solutions, like we said earlier, because it's a positive number for our discriminant. So let's go ahead and use that second formula. I'm going to rewrite it and leave some blanks. X equals negative, and a space for B, plus or minus the square root of the discriminant, and all of that divided by 2 times A. So, what goes in the first blank here? -11. That's our B. Perfect. Now instead of B squared minus 4AC and resolving all of that, we already found that answer. We solved for the discriminant earlier, so 25 goes under the square root. That's where that came from. We solved the discriminant first. And last but not least, what goes on the bottom? 1. 2 times A. 2 times 1. Now we only have 3 things to simplify rather than 5. Lot less steps to do at a time. So once we have our numbers all plugged in like this, and I see some of us are using colors and taking a lot of time to make their notes look nice and pretty. I'm going to be mindful of that and try not to go too fast today. And at any time, if I'm going too fast, tell me. I don't want to get anybody behind. So, let's just look at each operation happening. We have 3 operations. I have negative times -11. This is like -1 times -11. And then we have the square root of 25. And then we have 2 times 1. So let's go ahead and change all of those values. What does negative on the outside of -11 become? Just positive 11. Those 2 negatives will cancel out. And we get positive 11. The plus or minus stays. We'll go ahead and bring that down. Now we need to find the square root of 25. What is the square root of 25? 5, because 5 times 5 is 25. So that is our square root. So 11 plus or minus 5. And last but not least, 2 times 1 is just 2. Good. So we cross off each item we finish as we go, and now we're here. See how much faster that was? I think that was a little faster. So now that we have no more operations to do, nothing can really be simplified here, what step do we go to next? Yeah, we're going to separate our addition and our subtraction symbols so that we have the two values that we need to find. So what does my first problem look like? Good, 11 plus 5 over 2. And my minus, what does that look like? Perfect, 11 minus 5 over 2. Okay. Now, whenever I'm at this step, can I just type it in all at once? 11 plus 5 divided by 2, enter. Why can I not type it all at once in my calculator? Order of operations, yes. If I type this in all at once, my calculator is going to think, okay, I've got addition, I've got division. I'm going to do 5 divided by 2 first, and then I'll add 11. If you do that, your answer will not be correct. We need to only add the top numbers first, then divide by 2. The trick to getting around that on your calculator is whenever you type it in, if you want to do it all at once, just put parentheses around 11 plus 5, because in the parentheses, you see that is the first thing in the order of operations. So, what is 11 plus 5? 16. Divided by 2 is 8. We got one of our answers. Okay, now what's 11 minus 5? 6. Divided by 2 is 3. Those are our values of x. So our answer overall, we would say x equals 3, 8. The order does not matter. You can write either one first. I'm fine with either. But those are our answers. Okay. Now that we've gone through one problem, before we do another, I want someone to come up with one question that you think may be helpful to your classmates. Yes.
So whenever you get an answer of a decimal,
Yes.
you have to put the two numbers after the decimal, because some of them land in the middle. So I don't know if you have to use 3 numbers.
So like if, for example, we had 16 divided by like 3 and we got a long decimal at the end. So I always say, just as a rule of thumb, if you get an answer that has decimals, you don't get a whole number, I think it's a good idea to keep at least 2 decimal places. But whenever I'm grading your work, I'm not going to be super specific on do they have the exact right 2 numbers. If you're off by like 0.3 or so, that's okay, as long as it's in the same ballpark. But the best rule of thumb is keep 2 points and you should be good. Does that answer your question? Okay, perfect. Perfect. All right. We want to try another one? Let's do another. So that was number 5. Oops. Let's look at number 6. And on our worksheet number 6, we started with x squared plus 7x plus 15 equals 5. Okay, so what was the first thing we had to do with this problem? We needed to subtract 5, perfect, because we want our equation equal to 0 before we start doing anything. So minus 5 on both sides. And when we did that earlier, we ended up with x squared plus 7x plus 10 equals 0. giving us an A of 1, a B of 7, and a C of 10. Now, when we did number 6 earlier, what was the discriminant we found? 9. The discriminant, b squared minus 4ac, we found that it is 9. And because we got a positive number, how many solutions should there be? 2. 2 real solutions. So whenever we do our quadratic formula, we better get 2 answers. All right. So once we know the discriminant, we know there's 2 solutions. Now let's use that simplified quadratic formula. And we'll start plugging things in. We have x equals negative b plus or minus the square root of the discriminant divided by 2 times a. So what goes in the first blank?
7.
7. Good. That's our B. What goes under the square root? 9. Our discriminant. There we go. And what goes in the blank next to 2? 1. That's our A value. Perfect. Perfect. Okay. So, bringing it to the next step, I will get x equals, I've got a negative sign, I've got a positive 7. What do I write after x equals? Negative 7. Good. Then we've got our plus or minus. What is the square root of 9? 3. 3 times 3 is 9, so 3 is the square root. Okay, and last but not least, 2 times 1 is 2. And we've simplified everything we can. So where do we go from here? Plus or minus. We're going to separate our problem into 2 new problems. My plus. So whenever we rewrite our problem, the only thing that I see as one of the more common mistakes is losing a negative sign. You forget to copy it down as we go to the next. So we need to write negative 7 plus 3 divided by 2 and negative 7 minus 3 divided by 2. All right. So let's do the plus first. What is negative 7 plus 3? Negative 4. Divided by 2. What's my answer?
Negative 2.
Perfect. Negative 2. Good. Okay, and now negative 7 minus 3?
Negative 10.
Good. Negative 10. And divide by 2, what is it?
Negative 5.
Yes, negative 5. So, these are our two answers. So we will write them together as x equals -2, comma, -5. And just like our discriminant told us, we do have two solutions. And there they are. Okay. Okay. Give me a question. One more question, at least. Unless there's absolutely none.
Yeah, so like when you get to the part where you're finding the, like the plus or minus. Like
Yes.
X plus or minus. So that's really just saying it's like there, you still have to simplify that part. Like it's just saying it's two different.
Yes, yes. It's like we're kind of condensing the two equations that we're simplifying at the same time without having to rewrite all the numbers twice. So we just keep it as plus or minus the whole way down until the end whenever it really matters. No, that's a great question. Absolutely. So that's why we do that. Uh-huh.
Okay, so when we start off with a problem,
Mm-hmm.
do we have to break it down first, like separate the two sides, or can we find the discriminant first?
So anytime you have a problem to start with, let me start a new page real quick. Anytime you start with a new problem, if your equation is already equal to 0, you can just go ahead and get started. If I have my ax squared plus bx plus c, if it's already equal to 0, then I can go ahead and say, okay, this is a, this is b, this is c. I'm going to find my discriminant. I'm going to solve the formula. The only time that we need to rearrange the equation first is if it's not equal to 0. We need to get it there first. So we could make a note of that. Let's see. Before solving or finding discriminant, so before doing any of that, your equation must be equal to 0. And that is a very important thing to remember. Because if your equation has a number at the end that is not 0, then whenever you plug in your values of A, B, and C, one of those might not be the correct number. And in fact, one of those won't be the correct number since you don't have it in standard form. We just have to have our equation equal to 0. Now, does that answer your question? Or were you asking? Okay, perfect, perfect. So that is the most important part. Always will be step 1. Make sure it's equal to 0. Okay. And I'm gonna write that.
Another question.
Yeah,
Why don't we use the square root on the A?
on A. Let me see. What do you mean by that?
So number 6,
Number
and
6.
with the 1, they got x squared.
Let me go back. Number 6.
When we begin with x squared.
When we begin with x squared and A is 1, not 1 squared.
Yeah.
Okay, so what's happening here is x squared, whenever we have a square, or that to the second power on a variable like it is here, we're saying it's x squared. The 1 is just telling me that there is one of these. This squared, or the 2, is just part of the variable. And that's why x squared and x are not the same. They're both x, but this one is x squared. So this is one of those concepts that feels odd for me to explain just because I feel like I don't have great words for it. But I feel like the best way that I can describe it is the squared is only to whatever is right next to it. The 1 is not right next to it. It's over here. X is right next to it. So it's only happening to the number if it's right next to the number. But we have a letter in between the number and the square. Does that make sense?
Yeah, it just don't get used, so I was just kind of
Right.
used to it.
So why is it there? Let's maybe talk about it. Let's see. So in any equation that we're used to seeing, we just have an x. You know, we don't normally have a square on our variable. I wonder if this would make a little more sense. What if I gave us, I'm going to give us a random equation, and this is not part of our notes really. I'm just going to do it on a separate little sheet here. What if I had x, okay, 3x squared equals, let's see, I want 27. Okay. And let's say I wanted us to solve for x. So if this was just 3x, our first thought would most likely be, let's divide by 3 on both sides. Is everybody with me there? Okay, so let's start with that. Let's divide by 3. Now, what happens to my 3's? They cancel. Does the x or the squared change at all? No. Why is it not changing? Does anybody know why? Yeah, the 3's are canceling, and the 3 doesn't really have anything to do with that variable. It's just telling you the amount of x squareds that there are. X squared just means that instead of 1x, there's x times x. And there's 3 of them, so really there's like 6 x's being multiplied by each other here. But I'm dividing by 3, and now I'm going to bring everything down. I have x squared equals 27 divided by 3 would give us 9. So whenever we have this part of our problem, we haven't done problems like this together, but I'll show it to you. I'm not going to be quizzing you over this, but I think it is interesting to know. This is what happens when we have x squared. If I want to solve for x now, I haven't solved for x yet. I haven't. I've solved for x times x. So what I need to think of now is, how could I figure out what number can I put here instead of x that when I multiply it by itself, it is equal to 9. So in a way, let's see. Does anybody know the opposite of a square?
It's a square root.
A square root. So let's do this. I'm going to do the square root of x squared, and I'm going to do the square root of 9. So that would cancel, because whenever we square root something, that means I'm telling you the number or the item, the variable, the thing that when I multiply by itself, I get what's under the square root. So the square root of x squared is x, because x times x is x squared. So now I have x, equals, what's the square root of 9? There's two options actually. I heard somebody whisper it. It's 3. It's 3. Okay? So we have 3, but we could also say negative 3 because 3 times 3 is 9. Negative 3 times negative 3 is also 9. So the only thing that's really happening on our variable in this problem, whenever we have an x squared, it means that whatever number x is, I should be able to replace it in this problem with x so that, like, for example, we said our x is negative 2 and negative 5. When I put negative 2 into this problem for x, I'm going to have, let's actually do that. Let me move this to the side and make one more note page. So here's that original problem. Let's see. X squared plus 7x plus, it was 10 after we fixed it, equals 0. Okay, so we found that x equals negative 5 and negative 2. So this should be true, and we can see if it's true by taking the negative 5 and replacing, anytime we see x, we're going to write negative 5. So instead of x squared, we have negative 5 squared plus 7 times x. Now we're going to write 7 times negative 5 plus 10 equals 0. If we solved our problem correctly, then when I do negative 5 squared plus 7 times negative 5 plus 10, I will get an answer of 0. So let's see. Negative 5 times negative 5, what is that? 25. Plus, what is 7 times negative 5? Negative 35. Plus 10. Okay. Should be equal to 0. What's 25 minus 35? Negative 10. Plus 10 equals 0. What's negative 10 plus 10? 0. Is 0 equal to 0? Yeah. So negative 5 is a correct answer for x. That's what we're finding when we solve these problems. We're still trying to figure out what value, what number can I put into this problem that will make it true. I need it to equal 0. So these numbers work. We could also do it with negative 2 and it's also going to equal 0. Does that help us like kind of wrap our minds around what we're really doing here?
Yes. It's
Good.
kind of like a problem checker too.
Yeah, that way you can check your answer. Let's check negative 2 also while we're at it. Let's just see. We have negative 2 squared plus 7 times negative 2 plus 10, and it better be equal to 0. Okay. So we'll start here. Negative 2 squared is what? 4. Good. So I have 4 plus 7 times negative 2. Good. Negative 14 plus 10. What's 4 plus negative 14? Negative 10. Look at that. Plus 10. Negative 10 plus 10? 0. 0 is equal to 0. That's why those numbers work. When we put them in the equation, they equal 0. I think that's kind of cool.
Question.
Yes.
If you plug it into the original equation without balancing sides, would it still equal?
Yes. Ooh, I love that question. Okay, let's do that too. I'm going to move this unless anybody is writing it and they just want to see. Okay. So this was number 6, and we tried plugging it in after we rearranged the equation. So now let's plug it in. I'm going to write this here, actually, number 6. Our original equation was x squared plus 7x plus 15 equals 5. And when we used the quadratic formula, we found that our answers were -2 and -5. So let's check them. Let's see if it works. Okay, so let's try -2 first. Every time I see x, I write -2 instead. Let's do -2 squared plus 7x, so 7 times -2. Then we'll bring down plus 15 equals 5. And let's see if it works. Okay, so here's what happened. I just plugged in the -2 for x. And I'm going to also label this because sometimes I get ahead of myself and I forget that the point of taking notes is to be able to look back at them and understand what we wrote. So I'm going to write to the side, this is how to check your answer. If you want to be certain that you did your steps correctly, you can do this when you take a quiz. You can plug your answer back in and see if it works. So how to check your answer. Okay. So we just put -2 instead of x. So now let's kind of simplify each operation. -2 squared is 4. And 7 times -2?
-14.
Yes, -14. And then we just bring down plus 15. And this time, instead of equals 0, we'll bring down equals 5. So now we'll just do addition and subtraction from left to right. What is 4 minus 14? -10 plus 15 equals 5. What is -10 plus 15?
5.
It's 5. Is 5 equal to 5? Yes. So our answer is correct. -2 works. Kind of cool. We could do it with -5 as well, but I'll tell you right now it works. It works. Yeah, basically, it's a way that you can be certain you got your answer right. That's a good way to put it. It's a problem checker. Or an answer checker.
Yeah, you know what I mean.
I know it. All right. All right. Do we have any questions about that? Do we want to check another one, maybe? Or we feel okay about that? And we've done about 3 of them now. If anybody wants to see more later, I'm happy to show you my notes and my work, and we can run through together as well. Let's see. So before our break, we did some practice with the discriminant. You all did some discriminant problems on your own. You did great on those. Now, during the second half, we have gone to the next step, and instead of the whole quadratic formula, we have stuck the discriminant in. And we have sort of simplified the process of using the quadratic formula. So, I think now one of the best ways to kind of wrap all that up is let's create a bit of a guide so that whenever we do these on our own, we can remember what we did. So, this is kind of the first thing. Before solving or finding the discriminant, solving the equation or finding the discriminant, your equation needs to be equal to 0. Then we can find A, B, and C. Now, after you do that, step 1 will be to plug in your values of A, B, and C to that discriminant formula. Plug in A, B, and C. To the discriminant formula. And if I ever figure out what that word means, I'll let you know, because I really am not sure. I don't know why that's the name of it. Or quadratic. I don't know. I'd like to know like where they came up with these words. And what is the discriminant formula again? That's the second half of it. We've got minus 4 times A times C. What's the first part?
B squared.
B squared. There we go. Here's the whole thing. It's just B squared minus 4AC. That's how we find the discriminant. And then step 2, would be to plug in whatever you found the discriminant to be to the quadratic formula. So plug in D to the quadratic formula. And there are 2 ways we can remember this. I'll write the simplified version first, and that's where we have negative b plus or minus the square root of the discriminant. All of it divided by 2 times a. And if you're somebody that once you learn something one way, learning it another way does not really click as well with you, let's write the other way too, because they both work, okay? They both work, and I don't care which way you use. We have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. There you go. There's our formula. So whichever one you prefer is fine with me. Although you will need to know how to do the discriminant separately. So if you don't like using the simplified formula, just remember that whenever I ask you how to find the discriminant, you're finding what's under the square root, b squared minus 4ac. So just keep both in your notes, because you'll need it. But good deal. Okay. All right. You guys want to try doing some of these on your own? You don't have to answer. You're going to do it anyway. Okay, I'm going to leave that up in case anyone's still writing. And what I would like you to do is, let me look at that worksheet. I want you to try to actually use the quadratic formula now. We did number 5, 6, 7, 8, and 9 as a class. I would like for you to try. Actually, I'm going to give you some where we don't need to rearrange the equation, because in complete total honesty, I'm not going to give you any that you need to rearrange on your quiz. Okay, this is just something that is important to know for if you will use it in the future. However, on your quiz, I'm not going to give you one you have to rearrange. I'm just not going to. So let me actually just write out some that I would like for you to solve. And I'm going to say this is going to be your exit ticket. How about that? We're getting so close to the end of class. So, if you want to wait for a copy of this, you are welcome to wait, but if you want to just get started on it, that is fine with me too. You're welcome to write this down as I do. Just please make sure if you are writing your exit ticket yourself, label that it is the day 11 exit ticket. That way it doesn't get mixed up with other days when I'm grading things. So this is our day 11 exit ticket. This is your last exit ticket this week. I don't do exit tickets on Thursdays. So if you look at the board, you may notice, or maybe you've never noticed until I just now pointed it out, I have your assignments for the week. They're always going to be written on the board. Typically every week, you might notice now by the second week that you will always have 3 assignments. They will usually be very short and sweet. Shouldn't be too difficult to get them finished fairly quickly. You can make corrections to them if you make a mistake. It just needs to be done before Friday, this Friday. So, do Friday, April 11th at noon or 12 p.m. Okay. So, I want you, for each problem, to find the discriminant of each equation below. Okay, you will then tell me how many real solutions there are. And we talked about that briefly today. If you were not here for that part of the notes and don't know what I mean by that, you're welcome to come see me. I can run that through with you real quick. So that's the first thing. The second thing is how many real solutions and then the last step is to solve that equation using the quadratic formula to actually find what those solutions are. Okay. And I said do it of each equation. I'm actually just going to give you one because I'm asking you a lot of things about that one and I don't want it to take us forever. So let's see. How about we do Let's do x squared minus 8x minus 9 equals 0. Okay. And I'll leave you a space for each. D equals blank. There are this many real solutions. So there is 1, there is 2, and 3. X equals, and there should be, depending on your discriminant, either 1 x value, 2 x values, or no x values. If there's no x values, you'll just say no real solutions, and you don't have to answer 3. So that's our problem. I'm going to run copies of this. If anybody wants those copies, feel free to wait. I'm going to make enough for everybody just in case, especially for those that aren't here. But that's going to be it today. So I will end our recording, and I'll be right back with a copy of this.